right, let's see here. (36) Function C computes the circumference of a circle. Oh, okay. Right, that one?
Yeah, I started C and then in parentheses X equals 2 pi r. I don't know if that's...
Well, the problem with that is, so if I see this, I expect to see over here somewhere there's going to be an X. That's what it means to be f of X does something to X. But if you write this, which is totally correct, that's the circumference formula, it should be C of...
Of X? Or...
What's your variable?
Of R?
Yeah, that's all. Nothing major. So if you wrote C of X, you should write 2 pi X. But we don't do that because we just call it R for the radius. So that tells me what I'm plugging values in for. So for a different circle with a different radius, I'm going to change the R. That's what this does. It tells me what part of this am I going to be able to change with different numbers. So if he said C of X, I'm like, there's no X over there. What the heck? I can't change anything. Oh, shit. No, yes, yes, no. So if you see this somewhere in your travels, if you see this, I mean that's crap. That's evil. That doesn't make any sense. What does G do to Y? It multiplies X by... No, what does it do to Y? So that makes sense. Well, that makes sense. What does G do to Y? It multiplies Y by 4. There you go. So what's in here tells me what my variable is over here. It may...
And I put the input C, input 10, and if it's looking for the radius, wouldn't it be half of 10 or?
No. It's because when you write this, what is R?
R is the radius.
R is the radius. So if the radius is 10, what's the circumference for a radius of 10?
2 times 3 4.
Well, the radius is 10, right? So you just plug a 10 in for the radius. If they told you the diameter was 10, that would have been evil. You would have, oh, you mean R is 5, and then I would plug a 5
I
in.
don't know, I was thinking of diameter.
Well, you always, for circles, you always got to be careful about diameter, but don't be over careful. They didn't tell me the diameters, thank God. They just told me the radius, so I just got to plug that number in. Because that's what I need is the radius. I like it.
.6, page 402, number 15.
Yeah, this kind of problem is interesting because it starts off already factored, and the mistake people make is they unfactor the poor little dude, but it's already factored, right? So I got a number times another number is 0. So what's the idea? Either this number is 0 or this number is 0.
Okay, yeah, I started factoring.
Yeah, you started doing that, right? Because that's our brain says I got to distribute first.
Yeah.
But actually, this one I want to break it apart, and it's already broken apart. So just start making the parts equal to 0. Yeah. Okay. Anything else from homework?
Can you do number 107, please?
107 where?
Then 1, 4, 8, 4, 4, 6, 4, 8.
Whoa, there was a lot of numbers you just said. So what section?
Section 10.1.
Section 10.1, number
107.
107. Okay, thank you. Oh, this is kind of neat. So hopefully it kind of makes sense. If you're on the surface of the Earth area, I'm just hanging out. I can only see so far. I can see like right to there. And that's why when I look out over the ocean, it looks like the people way back when, they didn't know. They thought the ocean just kind of fell off the, holy shit, we don't want to go there because we're just falling. But it's just the Earth curving away from my line of sight. So that's why I can only see. So if I can get up higher, if I get on a mountain, then I can see further. I can see that far now, right? So this formula they give me in this problem, number 107 in 10.1, gives me this equation for how far I can see. Blah, 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 where'd it go? 1.22. So if I'm this far up, then I do this to see how far I can see in miles, I believe, yes. So this will be in miles. Let me make sure that how they gave you this formula. Example 4. Yeah, so this is in miles and this is in feet. So they give you this formula in example 4 and they tell you what the parts are. Is it cool?
To transfer from the feet to miles?
No. So 107 says if you're 10,000 feet up. So this is how far you can see. And this is how far up you are. And that's got to be in feet. It is in feet. So you just plug 10,000 in. And then solve for D. So D is how far you can see. X is how far up you are. So the way they constructed this formula is that input has to be in feet, and the output tells you how many miles you could see. Just so it comes out with numbers I can relate to. Yes, sir.
Is that 1.22 times the square root?
Totally.
Okay.
Yep. Anything sitting next
to
to...
a cube square or a cube root.
Only if there was a 3 there.
That, yeah, so that's not like a 1.22 root.
Oh, no. That would be like that, right?
Okay.
The number would have to be inside this little cradle. And that would, let's not talk about 1.22 root, that's freaky. It exists, but we won't talk about it.
That's good.
Good. I agree. But that's a good point. You got to be careful about coefficients versus are they actually the root. So the difference between this and this can sometimes be difficult to tell. That's 3 times the square root of x. That is the cube root of x. I like it. Cool.
Good.
So real quick, how many miles, if somebody was 4 foot tall, or maybe somebody's crouching 4 feet, how many miles out could they see? If they're, obviously this is if there's no building in the way. I can't suddenly magically look through the building. I can see them. No. So if I have nothing obstructing my view, that's the idea here. If I was 4 foot tall, how far could I see? Well, what's the square root of 4?
So,
What's the square root of 4? 2 times 1.22? 2.44. I could see 2.44 miles. So if you put your height in here, and you've got like an unobstructed, like you're at the ocean, unobstructed view. You put your height in here, you can tell how many miles out you can see. This is a decent approximation formula. Yeah.
so that's 100 times 1.22.
Where am I? 100? Where's the 100? Oh, here. For this problem, yeah, you put the square root of 10,000 in there.
And that's 122 miles.
Exactly, 122 miles. If you were 10,000 feet up in the air, you could see 122 miles out over the surface of the earth. I like it. Woo. But even if you were way up, you could still only see to the edges of the earth. You can't see the other side of the earth, right? There's like an extreme. If you're way up, you can still only see this half of the earth, right? And you're not suddenly going to be able to bend your eyesight around like the wanted thing with the bullet. You can do that with your eyesight. Well, no, you can't do it. I'm sorry. Sorry, if you don't get the wanted reference, I'm sorry. It's probably for the better. It was okay, but okay. Anything else from homework? Let me catch up real quick with who just came in. You want to take homework? Okay, so there's no other questions. All right, let me give you this. On one side of this is the practice test. I'm going to have the answer key on Tuesday because their test is happening Wednesday. I like it. So Tuesday's going to be review day. The other side is what I want to look at right now. It's section 10.3. So if you weren't here yesterday, throw out section 10.2. And I've got the homework assignment at the top of this for 10.3. It's a very short homework assignment. Oh yeah, graded as far as I could. All right. So before you look too deeply at that handout, let's ease into the idea. So one side is a practice test, the other side is what we're going to do right now. Let me get the idea going, and then we'll see what that handout says. This is section 10.3. This is the last new thing of the semester. Holy shit. So remind me real quick, if you had this here, what you got, John? Let's do, you can do it. I want something more interesting. Yeah, sure. So 225. Do you know what the square root of 225 is? All right. You don't know. Your calculator knows. So let's back it up. Does anybody know what the square root of 225 is? No. So what do you start doing?
Start with 5. Or did
Good.
you say also we could add the numbers?
Well, yeah, if you add the numbers, that's one way to tell if like 3, 6, or 9 goes into a number, right? So I gave you some different ways. If the last 2 digits of any number in the universe has 4 go into it, the whole number has 4 go into it. Those kind of rules. The easiest ones to remember are the 3, 6, 9 rules. If it sums up to be a multiple of 9, 9 goes into it. But to be honest, the easiest thing to see is it ends in 5. So obviously 5 goes into it. Is that cool? And why are we doing this? Because we don't know what the square root of 225 is. So I need to break it down to see what it's made of. Because the whole idea of a square root is to find how many of something in here. How many of something? Why can I do the square root of 49? Because there's how many things in 49? There's 2 7s in 49. That's why I can do the square root. So I'm looking for groups of 2 things.
Yes.
Does that make sense?
Yeah.
So cube root, I'm looking for groups of
3.
That's insane. Okay. So if I do 5 into that, 5 times what?
25?
5.
25.
5 goes into 20.
4 times.
5 goes into 25.
40.
45.
Okay. All right. A little concerned. And that's 9 times 5. And 9 is?
3.
So what do I see 2 of? I see 2, 5. So what can I write over here?
5 times.
5. Because the square root of 25 is 5. The square root of 9
3.
is 3. So the square root of 225, we're finally catching up to the calculator. 15. I like it. Now, you don't have to do that for everything. If I ask you what's the square root of 64, don't start breaking that down. You should know the square root of 64 is 8. Yeah.
What if there are uneven number of factor numbers?
I like it. That's what we're getting into. That's where we're headed with this. So I wanted to start with something we talked about yesterday, and now we're going to get into what section 10.3 is all about, which is this. What if I said, what's the square root? In fact, even here, I really want this idea to make sense. Let's take a step back in time real quick. Can I do 8 divided by 3? Can I do 8 divided by 3?
Without
Not nicely, no. I want it to come out to be a nice, like 8 divided by 4 is 2. Can you do 8 divided by 3 and get a nice number? No.
2 over 1.
Yes, so I could make it into a mixed number. Now here's a neat way to do it. 3 doesn't go into 8, but 3 goes into what? That's less than 8. 3 goes into 6. So I can write this as 6 plus 2 over 3. I really, no, what the hell am I doing? I thought we were talking about radicals, so just hang on. I break the 8 up into a part that I can divide by 3 and a part that I can't. So then I divide the part that I can. What do I get? 6 divided by 3 is 2. What's 2 divided by 3? I don't know. So it's 2 2/3, right? Do you guys understand what I'm saying?
Yeah.
Am I saying you have to do every mixed number in the world like this now? No. Because you can just do 3 into 8 goes twice with 2 left over. Ooh, 2 2/3. But this matches up with what we're about to do with radicals. And it's the same idea. It's the exact same kind of idea.
I know it's okay, but what about the sign of addition? It's, we can divide.
No. So what did I just do? 6 over 3 plus 2 over 3. As long as you do this to both. You can't just do this and make it a 2. 2 plus 2 is 4. You can't say the answer is 4. That's insane. 8 divided by 3 is not 4. As long as everything, you can break it up. That was the point of that whole little section we did where we broke it all up. I like it. Cool. Okay, so what's this got to do with what we're doing now? I don't know. Oh yeah, I do. What's the square root of 18? I don't know. You can estimate it. What would the square root of 18 be about?
Like 4 and
A little bit more than 4.
Yeah.
A little bit more than 4, because 18 is just a little bit more than 16, right? Just like I can say, what's 8 divided by 3? It's a little bit less than 3, because 8's a little bit less than 9. Do you see? Guess maybe? No? 8 divided by 3 is a little bit less than 3, because 8's a little bit less than 9. So when I divide 8 by 3, the answer should be a little bit less than what I get when I divide 9 by 3. Just that's how you kind of estimate what the answer should be. But estimations are only good for some government work. I want to get the exact answer. That's how I get an exact way to write the answer. So I want the same idea here. I want to be able to simplify this. In fact, I call it reducing the radical, because it's a lot like this. It's kind of like simplifying the radical.
4.
No. Here, division, how can I say this, can be split up across addition. Square roots can be split up across multiplication. Because what are square roots? Where are they in order operations? They're just like exponents. And exponents are based on multiplication. So how can I split this up into 2 numbers that multiply where the square root works on one of them? What's 18?
4 squared plus 2.
18 is 9 times 2. And I can do the square root of 9, can't I? So this is going to be the square root of 9 times the square root of 2. So it's just like here, I broke that up, and then I broke that up, and then I did the part that I could, and I didn't do the part that I couldn't. So I break 18 up, break that up, I do the part I can. What's the square root of 9? 3. And what's the square root of 2?
1.
I don't know.
4.
3 rad 2. I want the exact answer. And that decimal would never stop. That's the exact answer. So it's really just like this. Why is this going to have a remainder? Because 3 doesn't go evenly into 8. Why is this going to have a remainder? Because the square root doesn't handle the 18 directly. It can only handle a part of the 18. Let's do some more. Hey, real quick. Let me do this one a different way. So this is the way that I like to do this, because less mistakes are made this way. But I'll show you another way, and I'll show you the mistakes that are made. So if I look at this again, do I know what the square root of 18 is? No. So what do I start to do?
9.
Break it up. So it's 9 times 2, and I keep going.
3.
So it's 3 times 3 times 2. So what do I see 2 of?
3.
So I know the square root of 18 is 3, and that guy, there's not 2 2's. So where's that 2? It's still inside. Same answer. So if I see 2 of something, I can take one of them out. But if there's only 1 of something or something, I gotta leave it inside. It can't come out. Yes.
Is that the same when there's 3 and 2 of something?
For a cube root, sure. Is that what you mean?
No, I mean like if you factor it out and there's 3 2s and 2 3s.
Okay. Here we go. So what's 72?
236,
I like it. So 36 times 2, keep going.
218,
2 times 18, keep going.
29,
2 times 9, keep going.
33.
So what do you see 2 of?
3.
I see 2 3s. I like it. So 3 times.
2.
I see 2 2s. 2. Is anybody left inside?
Oh.
That poor little 2 there is hanging out. What's a more direct way to do this? Well, what's the square root of 36? 6. And what's the square root of 2? I don't know. That's the way I prefer to do it. But if you like better to break things all the way down, if you like that method, it works still. The mistake I see is people write this for some reason, they write it that way. It doesn't make any damn sense. There's only 1 2. How did it get out here? No. So they write it backwards when they do it that way. I don't know why, but it just happens. Okay. Let's do another one. So it should feel sort of like mixed numbers. You have a remainder that's going to stay inside. Why does it stay inside? Because there's not enough of it to come outside. Does that make sense? I mean, what's the square root of 49? Why?
7
7.
There's 2 7s in 49. What's the square root of 7 then?
We don't.
The square root of 7, I don't know what the hell. There's only 1 7, so it's got to stay inside. I can't simplify it because there's only 1 of them. The square root needs 2 things in there to be able to be done. So what if I had square root of 50? Let's do this my way.
A little bit more.
What goes into 50? Now I don't want an estimation. It's a little bit more than 7.
2 by 25.
25.
Beautiful. So why is 25 a good number? Because it is a square, right? So I know 10 goes into 50, but why is that not good? 10's not a freaking square. You got to break it up into a part that you can do, and then the rest. So I can do the square root of 25,
By 2.
but I can't do. So if I break this up, square root of 25
5.
times square root of 2, yeah. So this is why I prefer this method. There's no question about who's where. The square root of 25 is 5. Square root of 2 is, I don't know.
So you call it's 2, the remainder, a radical.
Yeah, so the remainder, I love this, the remainder remains inside. That's why the saying remainder makes so much sense here, right? It goes into this evenly, but this is the remainder, so it remains inside.
So it's called the remainder.
You could call it the remainder. Yeah. Technically, it's not called the remainder, really, but
Technically called?
nothing. Just the part that you can't do. It's not even a technical word for it.
Because it's actually.
So that's why I made up the word, I used the word remainder, because it makes sense here. Right? It remains. It's what's left over.
So they have an infinite amount of
Yes. It starts off as 1.414, but it never stops. If there's a square root you can't give me a whole number answer for, it will be a decimal that never stops. It's an irrational number. Which is really weird. Square root of 4 is the beautiful number 2. Square root of 4.1 is disgusting. Square root of 3 is equally disgusting. It's kind of weird. Just go a little bit away from 4 and you're screwed, right? Okay, I like it maybe. Okay, so let's make sense of this handout then. And then I've got some problems on there for you guys to try.
So any square root that doesn't have an even answer will have a never-ending answer.
Exactly. Yep. And that's why, like, the Greeks didn't think the square root of 2 existed. They thought it was they thought that was an imaginary number because they couldn't locate it. They couldn't construct it. You know, give me a piece of wood that's square root of 2 long. It doesn't exist. Go away from me. Nowadays we know it exists. It's just weird. Okay. All right.
Can I have one?
Okay. Who else needs one of those? Everybody got one of these? Okay, okay. Alright, so I show you both methods here. I start off with the method that I personally prefer because there's less mistakes made. But if this method makes more sense, you can use this method all day long, just be careful. So, like square root of 28. 28 is 2 times 14, but why is that dumb?
Because you can't square 14.
Because neither 2 nor 14
are rootable.
are rootable. I like it. So you're using my adjective, square rooted. They're not square rootable. But 4 is square rootable times who cares? So you're trying to break the number that you're given down into a part you can square root times whatever the hell else makes that number. So then the square root of 4. Now here's the trick right here. Here's the thing I want to focus on for a minute. The fact that you can do that. Let me really focus on that for a second here. Okay, Jeff, we'll let you do it. Okay, thank you. Fine. I need more blank paper. So really quick, what is 5 times 3? 15. Why am I able to do that? Because both 5 and 3 have the same root. We've never said that before today because we didn't talk about roots before. They both have no root. They're like 5 and 3. So I can only multiply the square root of 5 times another square root of something. So what would you hope the square root of 5 times the square root of 3 would be? Square root of 15, and it is. And just to make sure that you buy into this. So I should be able to go the other way then. I should be able to break that up, which is what I'm trying to use now, right? So if I did the square root of 36, isn't that the square root of 9 times 4? You guys with me so far?
Yeah.
And what's the square root of 9? 3. And what's the square root of 4? And is the square root of 36 equal to 6?
Yes.
Yes, okay. So it's not a proof, but that shows you that as long as the root's the same, you can put them together or take them apart. So I could not do this. I could not do the cube root of 7 times the square root of 4. Why can I not combine those?
It's not
But
They don't have the same root. But what's the cube root of 7 times the cube root of 4? Cube root of 28. So as long as the root is the same. So everything we've done ever, like this, normal numbers, we were able to do it because they both agree. They have the same root, namely no root.
Oh, we
So they-
don't change the root, yeah.
So
We don't change the root.
you can't, yeah, exactly. You can't change the root. I like it. Because the cube root of 7 times the cube root of 4, that's like 1/3 of 7 and 1/3 of 4 in a way. Because what does the cube root do to something? Breaks it down into thirds. So overall, I got 1/3 of 28 in a way. It kind of maintains that I got 1/3 of these things. Maybe. It's kind of freaky. So let's go back to this. So I'm always trying to think about the largest square number. So give me some square numbers. 1. What else is a square number? You can do it. 4. There it is. 1, 4, 9,
81.
16. See, that's what you're thinking when you see a square root. Does 4 go in? Does 9 go in? Does 16 go in? Does 25 go in? Why would I do that? Because those are the numbers that'll make it work. So when I see square root of 54, 4 doesn't go into 54. 9 goes in, good. 9 times 6, kick ass. So then the square root of 9 I can do, and the square root of 6 I cannot do. Kick ass. But just to show you, here's the other method on the 54. So if I keep going, 3 times 3 times 3 times 2, what do I see 2 of? 2, 3. So I can put a 3 out here, and then this 6 is still inside, because there's only one of each of them. That's how that other method works. If you want to break it all the way down to its DNA, there's the DNA of the number. Every two things you put out, everything that only one of you leave in. All right, cool. Yes, sir.
Okay, say you're able to pull 2 things out, then you multiply them. Right?
Exactly, because the whole thing is multiplied, right? This is all connected with multiplication. So whatever does come out, you multiply. Because it's connected by multiplication. I like it. Maybe. So, let's try to do this. Everybody's got a sheet of this, right? Everybody's got this? If you want to work together, feel free. Try to do these. I'll tell you right now that there are 2 of these out of these 10 that don't work. You just stop. You can't simplify it. I'll tell you that right now. Only 2 of them. The rest of them work. So it starts out with a nice one. 2 of them we already did. You can use either method you like. Second.
Thing number 1.
No, we did it.
Yeah, we did it. It must work. You made it work. An extra sheet of what? Oh, I don't have the answer sheet.